of these SMO Junior competition problems. They're about my level, you know. Even some of the senior problems get kind of tough for me, but I like these. They're right in range of stuff that's accessible to me, and I think they're interesting, and each of them has their own little challenge. They're not quite as difficult, but they still present their challenges, no doubt. Now, this particular question is a kind of an elementary combinatorics, the mathematics of counting problem. Well, we have this long list, and in fact, down here I've counted the number. There's 921 values in this list, starting at 1100, terminating at 2020. And our task is to count the number of multiples of 11. Now, you can certainly see that 1100 itself is a multiple of 11, right? It's 11 times 100, all right? But we had to figure out where to stop in this list. You can see by this long division result that 2020 is not a multiple of 11. 2020, the last element in the list, is not a multiple of 11. It does have a remainder of 7. Now, you guys may think this is overkill, but this is what these guys have to do. They can't use calculators. So they have to figure out somehow or that you have a remainder of 7. But I think it's kind of nice here where you can just show, there's no guessing going on here. This is true by just a tedious long division. And then if you multiply through by 11, you get this statement, right? And where you have 7 as your remainder. But if you subtract 7 from both sides, you get 2013 would be the last multiple of 11 in the list. Okay, so in other words, it would be buried somewhere. Let's see here. 2013 would be somewhere stuck in this ellipsis, right? So 2013 is in there, right? And it's clearly the last multiple of 11 in the list. All right. Now notice right here, you have to add 1. This is a little sneaky when it's not just a simple one-off of subtracting the smallest number from the largest number. You have to add 1. And the way I remember it and the way it makes sense, just think of a single die, right? It has 6 faces. Okay, there are 6 faces on this 6-sided die, right? Not 6 minus 1, which is a common mistake a lot of us make. So you have to add that 1 to get an accurate listing. Now, 921 obviously is too much trouble to exhaustively enumerate. So we got to use some intelligence like this. And so by the very same kind of reasoning where we calculated this total length, it'll be the very same thing right here. You see we have 100 times 11 as the first multiple. 183 times 11 is the very last multiple in the list. So you would do 183 minus 100, right? And again, it's a common mistake for people just to subtract and think that's the answer, but you have to add 1. So this is going to be equal to 84. And so folks, you can rest assured that there are 84 out of the 921 values are multiples of 11, okay? 84 multiples of 11. And you can actually turn this into a probability. You know, if you randomly choose a number, what's the probability you would get a multiple of 11? Well, that would be 884 divided by 921. So that's another question they could ask. Anyway, I hope you guys enjoyed. Thanks for viewing.